Well, hi everyone, my name's Shuan and welcome to our webinar today. We've had a lot of interest, which is fantastic. Today is the start of National Reconciliation Day and behind me, or week actually, behind me you can see a beautiful image, and it's actually an image that we commissioned by local artist Richie Allen, and it's called River Dreaming. For obvious reasons. You can see a beautiful river running through the middle, and then we've got these two images on the side of the people sitting around together, which is what we're doing today. And this landscape is really all about healing the land and our connection to our country, and that's what we're also going to be focusing on today. So I'd like to acknowledge that I'm coming to you this morning from Ngunnawal land and pay my respects to elders past, present and emerging. So welcome to our discussion today, all about managing erosion. The reason we want to focus on erosion is because we think about erosion as basically a lose-lose situation. So erosion on your land or along your waterway means you're losing it for agricultural productivity. The soil and sediment, when it's washed into water, contaminates it, and Kyeelee will be talking a bit about that later on. It's got implications for stock health. Then, of course, erosion isn't very nice to look at, so we lose recreationally and also socially and culturally. And finally, we've got to think about our native plants and animals and the habitat that gets degraded when erosion occurs. Now, of course, some erosion is natural, but we have tended to accelerate erosion with some of our activities. So today I'm really delighted. We've got Lori Gould from the Rivers of Carbon program, which is the Australian River Restoration Centre's on-ground program, and I work with the Australian River Restoration Centre. And we've got Kyeelee Driver from the ACT government, who'll be talking about animal health and the implications of erosion and how that can actually impact on our waterways and stock health generally. And then we also have Kyeelee Driver, who's, Kyeelee, do you want to give a wave? She's up in the top corner of my screen. I'm not sure whether you can see her there, but she's coordinator today through the Regional Agricultural Land Care Facilitator role that she occupies with the ACT government. So thank you to Jenny. So the way that we'll run this morning is Lori is going to talk first. I'd really encourage you to use your chat function. So if you know about Zoom, or if you don't know about Zoom, at the bottom of the screen, you'll see a bubble, which is a chat bubble. And if you click on that chat bubble, a screen will come up on the side of your computer. And into that, you can type any questions or comments as we go throughout the webinar. And I'll be keeping track of all of those. And if there's opportunities in between Lori and Kyeelee's presentation, we'll look at some of those. Or we will have a session, I should say, we'll have a session where we can have questions and answers at the end of both presentations. So let's kick off, and Lori, if you'd like to take over the screen share.
It's nice to see so many people on, and I also recognise a lot of the names from landholders that I've worked with over the years, and it's wonderful. I can't wait to catch up with everyone again one of these days when we're offline and out in the field. But today I'm going to talk about managing erosion for multiple benefits, but most of my talk will be focusing on actually what is erosion, the different types of erosion, and some of the ways that we manage it on farm. So it's got quite a practical focus. And Kyeelee's going to talk about stock health in relation to that. So I won't go into details about that, but I will touch on it a little bit. So there's obviously, change please.
Yeah. How do I make it change? It's not moving.
Arrow button?
Yeah. Nothing's working.
Everything's falling apart this morning.
There we go.
Oh, we've got it. Right, okay. We'll get there. We'll get there eventually. That's fine. So obviously there's a lot of benefits to managing erosion, and a lot of that relates to river rehabilitation. But the main things I think are when you're minimising erosion and soil loss, you're also locking up a lot of nutrients and other contaminants into the soil. And so anything that happens in the catchment obviously ends up in our waterways. A lot of things like phosphorus and nitrogen are locked up in our soils. And so then when the land erodes usually from a lack of ground cover and other pressures, all of that nitrogen and phosphorus is released, and that's what is the main driver of our algal blooms. And obviously in drier conditions, we end up, it's perfect conditions for algae, so we end up with these huge algal blooms that we might remember from the Darling River and other places, but also you can see that on the farm as well, in downstream, particularly where water pools and there's a lack of flow. Fish are particularly affected by erosion. All of their breeding sites, a lot of our big iconic fish like the Murray cod and others, they all need rocky habitat to lay their eggs. And when that gets smothered in sediment from erosion, obviously they've got nowhere to lay their eggs. Similarly, big sand slugs that we get from upstream erosion prevent the fish from being able to move up and down river to breeding sites as well. So it goes a lot further than, I guess, what you think when you first think of erosion. Stock management, which Kyeelee is going to talk about, just having clean water for stock. Also managing stock around waterways. And then it also has an impact on habitat for wildlife and biodiversity when we're smothering a lot of the habitat for our macroinvertebrates that all of our fish and everything rely on to survive. And then also things like managing erosion can also help with things like wind shelter for stock if you're doing revegetation, reducing salinity, and also when we say increase capital value, what we mean is that it actually just looks better in the landscape. And I'll show you a few photos of what I mean as we go on. So erosion has a lot of different forms. We've got some really significant erosion, like that photo there on the left. Mass failure, that sort of erosion, sometimes we just have to accept as a new landform if it gets to that level. Very, very active. On the top right, they're reasonably active, but not too bad. It responds very well to ground cover management. But then we've got some very significant issues, for example, down on the bottom left in a wetland, where ultimately, if what we call those things head cuts, where there's a little nick point that's moving across the landscape, when they get bad enough, it actually drains all the wetlands around it and it completely changes the entire system. So that's down at Yayak, south of Canberra, and some work was required on that particular one just to protect that entire wetland that you can see around it. And then we've also got some other issues where, for example, if we have lots of crack willow that's choking up small streams, when the flow comes down, it deflects off the willows and actually goes into the banks, and that can be exacerbated by stock eating ground cover. So we've got lots of different types of erosion, and we sort of look at it. Each site that I would go to, I look at for the specifics of the site rather than broad generalizations, because it can vary. I've got a few more examples. You've got things like on the top left, that was once a swampy meadow that's been channelized. Often, particularly around the Goulburn area, humans tended to deliberately drain a lot of these swampy meadows to open up land for grazing and dried out the landscape, but then the channels just got deeper and deeper, and usually they kept going till they hit bedrock. I don't know what was the purpose of putting that car in there, but I'm sure somebody had some, and it just kind of highlights the way we used to treat a lot of our waterways as dumps. And then on the top right, there's been a disturbance that has created that erosion on the bank, but the erosion isn't particularly linked to the waterway in terms of it didn't start as stream bank erosion. Someone's dug out the side of the bank and then it continued to erode, whether they were extracting soil or some other reason. That's unusual in a natural setting. And then down the bottom there, you've got an active nick point or head cut that's coming off the side of a gully. And often gullies appear to be really active, but the main channel gets quite stable, and then you just have the active head cut, which needs treating. And then up the top there, we've got a very young gully, and they're of concern because they're quite new. A lot of the gullies in our part of the world, by that I mean Southeast Australia, occurred in between 1850 and 1900 when we had the introduction. There was rabbits and there was an increased level of agriculture. Around that time, things started more stock, for example. A lot of the gullies now are quite old and they're stabilising, whereas we still see these young gullies that sort of occurred in the 70s, 80s, 90s, 1970s, 80s, 90s, and they continue to erode. So when I see something like that, I get a little bit concerned because it's got a long way to go. Some erosion is simply from stock. Down the bottom left, there's a lot of stock damage, a lot of stock eating the grass there, but ultimately that system's pretty stable. A bit of ground cover would fix that. And then the bottom right, you've got very, very sodic subsoils where they're very alkaline and the soil particles don't stick together the way they would if it was clay. So it's very sodic, dispersible soil. And whilst the bed of that stream is stable, which normally is an indication of a system stabilising, there's still a lot of active erosion on the gully walls there, or the creek walls. And then we've got erosion that looks really horrendous, but is actually quite stable. So as I mentioned, a lot of these gullies occurred, you know, the late 1800s, and whilst we get this cathedral erosion, even the little head cuts coming off it are starting to stabilise, and the cathedral look is actually from rain action. So those gullies tend to look horrendous, but there's really only small parts of that we need to actually treat. And a good way of also just hiding them a bit is to plant some vegetation around them so that they're not as stark. The creek down the bottom was really interesting because the landholder there has been concerned about that for a long time. That's up near Cooma. That's all right. And when we did some analysis of aerial photos, which is one way to look at how much gullies have progressed since as early as we can get is about the 1940s, we actually discovered that wall has been there since then and hasn't moved. And we suspected it was pretty stable because the toe of the bank, which is where the wall meets the valley floor, is actually not undercut. It's well grassed over, and the water, when it flows down, actually doesn't flow against the bank, except in quite high flows. It's also got a lot of rock incorporated into the soil. So that landholder had been concerned for a long, long time, but after we did some analysis, discovered it really wasn't a concern, and he could go and invest his time in other activities on the farm. So stock are a big, in our landscape, stock are a big issue around waterways, just mainly because they not only create tracks that can cause erosion, but they also eat all the vegetation. And this is a big thing. They eat the ground cover. So stable soil equals grass. So anything we do, we sort of do it to ensure that there is good ground cover all the time, particularly around waterways. So some of the techniques that we use, the biggest one obviously is fencing, and most farmers will know this. Just 95% of sites that we've been through over the years, the last 25 years, really there was a big focus on soil erosion, using earthworks, soil erosion control from the 1950s onwards, really. But in more recent times, I think we've realised that most sites will respond just by maintaining ground cover. So the site up the top left there, the photo below it, that's literally within about a year and a half. I think it was 18 months. The farmer just put a fence around it. Ground cover grew. That site had a lot of native ground cover, and it's re-established before the landholder had even got his plants in the ground. On the right, the top right there, you can see those sorts of sites. Still a bit of active erosion, a bit of undercutting just by putting a fence around it. The photo below shows it's grassed up quite nicely. And in that case, because the channelization wasn't too severe, it's actually recreating a chain of pond system just through vegetation. So I think I personally just start at the do very little side of things. So go out to a site. If you can just put a fence around it, it's a lot more cost effective. than having to get in big machinery, which also can create disturbance. That's not to say there aren't sites that do require that. It's just that 95% of sites don't. So you don't necessarily need to do much more than that. I think in the case of some of the swampy meadows around Goulburn, putting a fence around just creates that buffer zone, stabilises the soil in those systems, and it also allows aquatic plants to grow. So the rushes and reeds, in some cases, kumbungi or typha that drives everybody nuts when it establishes really well in some of these systems, is controlled by depth and by shade. And so sometimes when you fence off a small creek like this, the kumbungi or typha can actually appear to be taking over, but it actually is a really good plant functionally because it has bacteria that converts ammonia to nitrate, so poo to plant food effectively on its roots. There's two types of bacteria that do this. So it filters the water, and it's also quite flexible in floods. And it takes a while to, where in the case where the landscape's disturbed and it does take over, it can take quite a long time to re-establish pools between it and that sort of thing. So some active management might be required, but we see it as a reasonably positive plant. But it is something that shows that if there's disturbance to the landscape, it will respond in that way. So that particular site was a grassy meadow to start with, so it didn't really require any re-veg. There's one weeping willow which was left there for a bit of shelter. Weeping willows are all females. They were only introduced females into Australia, and they don't cross with any of the problematic male willows like crack willows and that sort of thing. They're not as aggressive in their spread either. So the willow issue is not black and white, but most willows are pretty invasive in waterways, but the weeping willow is one that we don't worry quite so much about. So once you've fenced off your creek or stream or gully, revegetation as appropriate. For example, as I just mentioned, there was no revegetation undertaken in the swampy meadow, but a lot of gullies respond quite well to putting in trees and shrubs, and also to create wind shelter between paddocks, and for stock, as well as to help stabilise the soil. So you can see on the left there, the channel of the gully down the middle of that picture is actually stabilised with a lot of grasses and reeds as the trees are growing. So the first thing we see within 2 years is a good level of ground cover that comes back, and then the trees will obviously take a bit longer to grow. So here's a site out near Goulburn, and on the left there is actually the before photo of the photo on the right. And in this case, there was erosion, it was a bare paddock, and there was rubbish in it at the time. So just by removing that rubbish, putting a fence around it and planting a few plants, it stabilised quite nicely. It didn't require any earthworks or anything, even though it does have a bit of sodic subsoil there. And in this case, you can see the landholders put a lot of trees into that particular site, but the main channel is grassed up with reeds. And so revegetation can be interesting because if you put the trees too close to the edge of the gully, it can actually shade out the grasses. So in sites like this, the landholder obviously preferred to have the plants in that particular location because the carrying capacity of the land was a bit lower there. Works really well because the lighter country, the lower productivity country is usually the best for the conservation side of things. So it works well. And then in this case, he could up his production on the better country, increase stocking rates. There's shelter for stock and also shelter for lambing as well. So there was multiple benefits. And as a percentage of that property, which is about 10,000 acres or something like that, it's not a huge amount of land that is incorporated. And it's also wide enough and a big enough area to be able to put lambs in and to do some crash grazing from time to time. And there's just another view of it. I guess that's what I'm talking about with capital value. It's gone from a sort of an ugly scar on the landscape to something that looks a little bit more acceptable It looks and it's all the soil is locked up within that gully system now. Even bits of soil that fall off some of those bare walls get trapped within the base of that gully. So we're not releasing all the phosphorus and nitrates into the streams, the waterways downstream. And phosphorus is actually carried in very fine sediment. So you only need a little bit of soil loss to be putting a lot of phosphorus into the water. Similarly, in this case, if the landholder's super phosphating in the paddocks adjacent, these buffer areas will stop it, will lock it up and stop it ending up down in the rivers downstream. So obviously, if you're fencing off creeks and rivers, there's a consideration for how you're going to water your stock. And this, by putting in alternative stock water, which Kyeelee will talk about, actually can improve animal health. So you can control your water source and the water quality in that source a lot more closely. Obviously, there's different ways of doing that, whether it's people tend to put in dams less these days, just because with rotational grazing systems and that sort of thing, they tend to want some flexibility with how they water their paddocks or their paddock size. So they might go to a tank and trough system. Otherwise, you can also, create dams that have access areas for stock so that most of the dam remains well vegetated. So some of the techniques, once we've decided that, fencing and or revegetation and or stock water will be related to most projects, but then some sites that just won't stabilise with simply fencing and keeping ground cover, we require other techniques, but all of these other techniques are just designed to establish ground cover. So when we do rock armouring of stream banks, what we're hoping will happen is that we use angular rock, and that traps a lot of sediment, which ultimately we hope will grow grass. However, in the case of, for example, the top right photo there, that's at Jerrabombra. Developers and a lot of people that sort of the roadworks industry will put in these gabion aprons to stabilise waterways, and they tend to knock grass up quite as well. So free rock is always preferable if the rock's big enough to be able to withstand the flow. And I do happen to know that that is the second gabion apron that was put in that site, because the first one got taken in a flood, so it just undermined it and took it. But I do notice that gabions are a favourite of developers and roadworks. It's not the wrong thing to do, but it's a common theme, and I guess it's a technique that's applied broadly, perhaps without maybe that site-specific assessment. And then things like, for eons, landholders have been throwing rocks in gullies, and that's perfectly fine. The only thing to consider is that the rock size needs to be able to withstand flow, and some of the flows that you get down in a gully raker storm can move some really sizable rocks, as a lot of you will know. So it's just a matter of applying that technique as appropriate for the site. Earthworks are sort of our last resort in a way. We do use it. We do put in things like diversion banks, and you can see in the top right hand corner, it might be a little bit hard to see, but there's a bank going around the top of that gully. But what's happened is that the water's been concentrated and dropped off the end of the bank and created a second gully. And we do see that a lot around the landscape. So I know that certainly soil conservation type techniques these days have addressed a lot of those issues. So now we would put a bank that's further up above the gully. It will go further down the system, and they would construct a rock flume to drop that water into. But yeah, in the past, and I did read the Jubilee history of soil conservation services, which was extremely interesting. But as with anything new, banks and dams and fixing the landscape, humans apply it everywhere. So we think everything's the next sort of answer to everything and a panacea. So I think over time and doing this sort of thing, we realise we get much more focused on how we apply some of these techniques. And And we've got some wonderful operators in the earthworks field who do fully understand this. And I guess I use the photo on the bottom right there to illustrate this. Some soil erosion works create a huge level of disturbance. And while ultimately they look quite good, so the photo just above it there is how it turned out. And you can see a rock flume there where they've put the water in back into the creek. There was a lot of disturbance at the time, and I think that you know, we tend not to do that so much anymore. Battering of the edges of gullies, we don't do anymore. It just creates a bigger surface area for rain to erode. We just now very specifically treat the areas of issue, which has reduced a lot of the issues with having bare soil like that for weeks in some cases, particularly now when we have seems to be a predominance of drought. Drought followed by rain is just, you know, drought, there's no ground cover, big flows, lots and lots of erosion. And then flumes, they're my favourite actually, rock flumes. But so in some really, really steep catchments, Soilcon and people like that will advocate the use of concrete. And these days we build, in the past they used to just be a concrete apron, and you can see these around the landscape from years ago, which are holding up really well for the most part, but they've just modified the design a little bit to include that pool in the bottom to dissipate the water velocity before it gets put back into the main creek. And the photo up the top on the right is actually the before photo of the photo below it, where you can see the rock flume in there amongst the trees. And so the reason they're my favourite is because they're minimal disturbance, they're very, very natural, and ultimately when they trap soil, grass, natural vegetation will grow on it and create a filter strip. So the water stays going where it's going, but the area of concern is armoured. And then we've got things like in-stream works, and there's any number of different ideas. There's log jams, there's all sorts of things to treat the inner bends of streams. So the top left there, you can just see little rocks, I don't know what you call them, rock logs, I guess, jutting out towards the middle of the stream. And the idea of those is as the water flows down, it hits them and bounces off or deflects at a 90-degree angle. So the water's deflected back into the main channel rather than into the banks, and they're very effective. You just got to make sure the stream is not too narrow and that you end up taking out the soil on the opposite bank. So that's the New Morella River near Cooma, and that's quite wide, very, very sediment-laden river from decades of erosion in the catchment. Then we've got the classic rock gabions, bed control type structures. There's all different types of this. It can be anything from hay bales pinned in to these rock encased with netting. I think some in creeks and rivers there's a bit of a focus on leaky weirs, which is essentially the same sort of idea where you're putting structures in a stream to reduce velocity and create pools behind them. They work very, very well in the flat gradient areas, so in the flat swampy meadows. They're a bit harder to establish in a higher velocity stream just simply because of the size of the rock that you require and the number of structures that need to be built. So Soilcon have been doing them for, well, it's like for probably the last 50 years according to their Jubilee history. But also there's, in more modern times, they tend to be termed leaky weirs and put into those flatter valley floor systems to try to get water back into the landscape. And then we've got some, am I getting a time notification?
You're getting fish passage.
Oh yes, that's Shuan was making some kind of funny movement about a fish and I couldn't work out what she was saying. But anyway, yeah, the leaky weirs also have issues in some of our biggest streams just for fish migration. So they're a good technique, and they're just, I find that they need to be rather specifically applied. Rather, as I mentioned, we have an idea that you can do one technique everywhere, but over time you learn how that's best applied. So it's good to look at these things all as a big toolbox with lots of different tools in it, and then we can apply that as appropriate by looking at the landscape. So can you go back one, please?
Oh, sorry.
That's okay. I was just going to say that sometimes we've got really well vegetated areas, like the two photos on the right. It's very, very tricky to actually undertake any works in, but these systems are still quite active. So in this case, the landholder got a bit innovative and he actually went and hand placed rock. There was a lot of these little head cuts. Hand placed rock, a lot of work throughout this whole system. And if you look down the bottom there, you can barely notice what he's done, but he's actually stabilized that whole system just by being a bit innovative. And that, again, that was quite a slow moving system. So he didn't have issues with rock size. But yeah, people, as I said, you can put log jams in, there's groins, which are what those things up the top are called. There's rock armoring of streams. There's all sorts of things, effective things that people do in streams. So all of this is on the Rivers of Carbon and River Restoration Centre website. So if you're interested in anything in particular, there's plenty of resources, including how to treat an erosion head cut on your own property. If it's quite small, you can do some things yourself to improve it. So the purpose of all this, obviously, from our perspective, apart from the benefits that I mentioned earlier, we've also got some species, these species like the Macquarie perch in the top left there, the Murray crayfish, platypus and water rats, and I must acknowledge John Bartondock for those photos of the Ricali and the platypus, which all heavily rely on our rocky, not only intact banks, but our rocky habitat for their existence. So things like a water rat are a little bit more resilient. They're not as critically, but then they rely on the macroinvertebrates that need a diversity of habitat in stream to survive. Platypus obviously have burrows and lay their eggs. And certainly after the fires in 2020, we've noticed some really big impacts. So that little galaxis in the middle there, Stochygalaxia, we've nearly lost that Stochygalaxia purely because of the erosion. So the fires came through, lots of floods in February, and then all of the stockies habitat was pretty much smothered. So we have a Macquarie perch project at the moment where we're reducing sediment going into Macquarie perch hotspots in the Murrumbidgee, but the little stocky is suffering at the moment, and ecologists are trying to work out what to do with it. It occurs in the upper Cotter near the ACT, so reserve land, big sediment movement, and a lot of these animals suffer. And obviously the Murray crays, they really like rocky habitat to survive. We're lucky to have a lot of those in the Murrumbidgee River still. And I included a photo of a bird simply because of biodiversity. So by undertaking all of these works, we can improve the biodiversity. And our small woodland birds come back quite quickly when we put in a mixture of shrubs and trees. And we find within a few years, we can start to get little wrens and robins and other woodland birds coming back. So there are multiple benefits, as I mentioned earlier. And I might leave it there before I get the time, the time signal. And thanks all for listening.
You stay there, Lori. So I'm just going to appear. Oh, look, there we are from behind the painting. So very happy to take some questions at the end, but we might keep going right now. So Kyeelee, would you like to share the screen? Then you can answer that one.
Okay. Where is Kyeelee?
And you just need to go off mute, Kyeelee. She's just there.
Oh,
Oh, hang on. You know what?
You go down.
I can't actually share at the moment.
Oh, okay.
Our technology is just
Everything was working before.
it's amazing.
Okay, I think we're there.
Great, thank you.
Oh, we've finished it already. I've done well. Okay. Thanks, Laurie. There's some great examples on erosion and managing erosion. My name's Kyeelee Driver and I'm the ACT government veterinarian, biosecurity veterinarian, but I do animal welfare, animal health and a range of other things as well. So I've just been asked to very briefly talk about the benefits for stock health in managing erosion. So managing erosion can result in long-term benefits for livestock health, livestock productivity, and therefore your farm profitability. Erosion gullies, as Laurie said, reduce the land available for grazing, lead to sediment being washed into waterways, increasing turbidity, nutrient loads in your dams, streams and rivers. And as Laurie did point out, may be filled with waste such as old drums, car bodies or animal carcasses, which creates further erosion as well as potentially contaminating the water runoff. So improving the management of your erosion gullies can improve stock health in a number of ways. It may reduce the number of animal deaths due to misadventure around these gullies, due to the collapsing of unstable banks, the presence of waterlogged soil or drowning. It can improve farm biosecurity because often these areas are difficult to fence off. So that leads to straying stocks. That's both stock going out of your property and stock coming into your property. And straying stock may introduce diseases such as Johne's disease, parasites such as sheep lice, resistant worm populations, and also those weeds. It improves water quality, so cleaner water is going to be more palatable to livestock, which leads once again to livestock production gains. And turns around and will help reduce the risk of stock losses due to waterborne parasites and pathogens like leptospirosis, E. coli, Giardia, liver fluke, Cryptosporidium, the list does go on, as well as the potential for toxic algal blooms. So water quality and availability are extremely important for animal welfare and stock health. As you're all aware, water is an essential nutrient for both humans and animals, and relative to all the other nutrients that we require, water is consumed in considerably larger quantities. Now, while people will say, oh, no, my animals will drink absolutely anything, and indeed, animals are generally able to ingest a wide variety of different types of water and survive, good water quality is important for your stock health and for productivity. So given a choice, stock will actually drink and perform better with clean water. Now, the suitability of water for stock use is determined by a number of different factors. We've got the animal factors, so that's the age of the animal, the condition of the stock, breed differences, watering points. We've got environmental factors such as your air temperature, what the climate is, such as drought, your feed quality, if it's nice juicy green feed, and where your watering points are. And then we've got water quality factors as well. So you've got your salinity of the water, your pH and contaminants, etc. Often these factors can combine, so marginal quality water may actually become unsatisfactory during summer because your animals are drinking more of it due to the high temperatures and your dry pasture. So managing erosion will help improve stock water by improving the chemical and physical quality of the water, as well as improving alternative waters, providing alternative water sources, for example, troughs rather than dams. So there's a few considerations when you're looking at water quality, and we're not going to go into depth, but briefly, we've got the pH. The preferred pH for drinking water for stock is between 6 to 8.5, and depending on which source you look at, that does vary a little bit, up to 9. The hardness of the water. Now, stock consumption of hard water is generally not a problem unless magnesium salts predominate. And I'm sure we're all very aware what Epsom salts can turn around and how they can affect us. So it's can be a similar effect with cattle. Salinity and total dissolved solids. Salinity is a bit of an ambiguous term, but it is used as a convenient guide to determine the suitability of water for livestock. We've got turbidity. Water turbidity is simply defined as the clarity of water, so how cloudy it is, and it tends to be an indicator of how much solid matter such as your clay, silt, organic matter is actually suspended in the water. And then we have contaminants as well, your heavy metals, organic material, chemicals such as your pesticides, cyanobacteria, so that's your blue-green algae. Now, this is a bit of a misnomer because blue-green algae possesses characteristics of algae, so they make chlorophyll and they use sunlight as an energy source for growth, but they actually have bacterial cells rather than algal cells. And then we've also got pathogens, a wide range of waterborne microbial pathogens, bacteria, viruses and protozoa, and parasites can also affect stock health. I was just going to take a very, very quick look at a couple of the factors that affect water quality, not go into great depth. But if we turn around and look at the pH of water, pH basically describes how acidic or alkaline the water is. And as you can see from this particular picture here, it goes from 0 to 14, and numbers, 7, pH of 7 is pretty neutral. Little is known about the specific pH effect on water intake. However, the effect of water intake, stock health and production, or the microbial environment in the rumen. So not a lot is really known, but what we do know is that water pH below 6 or above 8.5 can cause what we call non-specific effects. So, basically might be a bit of, digestive upset, diarrhea, a bit of poor feed conversion, reduced water and feed intake. And they may, those lower and higher pHs may also increase the availability of toxic elements. However, generally pH in itself is not a water quality issue that we're concerned about with stock. But water pH is actually an important factor if you're determining the effectiveness of various water treatments. So in other words, if you want to turn around and chlorinate your water, chlorination efficiency is reduced at a high pH. If you're wanting to use water medication for your stock, a low pH may actually cause precipitation of some of those antibacterial agents that you want to deliver through your system, and therefore rendering them probably not very effective and probably not doing much to your watering system either. Having a quick look at another water quality factor, which is total dissolved solids. Now, total dissolved solids represents all the minerals, so the calcium, magnesium, phosphorus, iron, zinc, everything, plus your inorganic salts, carbonates, sulfates, plus your metals, plus your chemicals, herbicides and pollutants, and a small amount of organic matter. So it's the stuff that you can't see, but it's dissolved in your water. But total dissolved solids, when you get that result, is not really a specific, it doesn't tell you what specific substances are in the water. High total dissolved solids can adversely affect water palatability, therefore it affects water consumption, feed consumption, and animal performance. And what you'll see when I turn to the next slide, which is also salinity, is that while you've got different values between total dissolved solids and salinity, the effects on livestock are pretty similar in that some of these levels, your water will still be suitable, say for livestock, but not suitable for poultry. And as you can see higher up here, when we get to 7,000 to 10,000, it's the water would be unsatisfactory for poultry and pigs. Probably not particularly great to be using for any animals, but there are specific types of animals such as pregnant lactating cows, etc., that you're looking at a considerable risk if you are using water which have these type of values. Salinity is a little bit ambiguous term, and really what most of the measurements you would get if you were getting a water quality analysis, they're trying to help you characterise salinity. As a basic definition, salinity is the total concentration of the mineral salts dissolved in the water. So this is your sodium, calcium, magnesium, chloride, sulfate, carbonate, with the most common salts being sodium chloride. However, the mineral salts that you would find in the water are actually dependent on your surrounding environment. High levels of mineral salts in water can result in gastrointestinal symptoms and a reduction in weight gain and milk or egg production. So the effect of salinity on stock health and productivity really depends on your species, breed and age of animals that are drinking the water. For example, animals that are under stress due to pregnancy, lactation or rapid growth are going to be pretty susceptible to high levels of salinity. It also depends on the feed the animals are consuming. If they're turning around and eating some lush grass, with lots of water in it, then that's going to be they're going to respond to the level of salinity in a different way to eating a much drier diet. Also depends on the ambient temperature and the water temperature, humidity, and which minerals are present in the water. So many of the minerals that are actually present in the water are essential nutrients for animal health, but some of them can cause chronic or toxic effects if they're present in elevated concentration. So for example, sulfur, it's an essential element or mineral, but for animal nutrition. However, excessive concentrations of sulfate in water will typically cause diarrhea and reduce performances in livestock. However, animals generally avoid water containing high sulfate concentrations. Calcium is another essential element in an animal's diet. However, high calcium concentrations may cause phosphorus deficiency because it interferes with the phosphorus absorption in the gastrointestinal tract. Nitrate and nitrite, both of these can cause toxicity to animals. And say symptoms of an acute poisoning, so that's a sudden poisoning would be increased urination, restlessness, vomiting, convulsions, and potentially death. But stock can tolerate higher nitrate concentrations in drinking water, provided that the nitrate concentration in their food is not too high. And another element is magnesium. That is, an essential element for animal nutrition. And in high doses, magnesium can once again cause scouring, lethargy, so tiredness, lameness, decreased feed intake, and decreased performance. However, stock can acclimatise to some extent to water of a high salinity, but generally it does need to be over a period of time, several weeks. But sheep do have a higher tolerance of salt concentrations than cattle. And finally, I was just going to very quickly go through, look at contaminants. So a variety of contaminants can enter water sources and be potentially harmful to livestock, as well as being a food safety concern as well, because many of these, the heavy metals, actually stay in the animals right up to slaughter. So it can become a food safety concern. So some of these contaminants would include heavy metals. Many metals, once again, are essential nutrients for animals' health, but elevated concentrations can cause chronic or toxic effects. Stock can once again tolerate many metal elements in drinking water as long as they are not ingesting them in high quantities in the diet, because they do accumulate in the body, and that the rate that they accumulate depends on how much they're ingesting from both water and from food. We've got organic material as another contaminant. That's your debris and dead animals, chemicals such as pesticides, cyanobacteria, or your blue-green algae. Just because you see blue-green algae does not mean that the animals are going to be poisoned. There's many different types, and it can also depend on whether they're actually drinking near where the blue-green algae is. So yeah, it's a matter if you see blue-green algae to actually get it tight, but remove animals immediately from that water source. But not all blue-green algae will cause signs of toxicity, such as weakness, lethargy, anorexia, paleness, and ultimately death certainly can occur. And then we've got pathogens. So there's a wide range of waterborne microbial pathogens, so bacteria, viruses, and protozoa, as well as parasites that can affect stock health that live in the water. So these are things like leptospirosis, salmonella, fusobacteria, botulism, especially in stagnant and non-flowing water. So water quality affects stock health. You'll see a range of clinical signs, depending really on your environmental factors and your animal factors as well. So you can see decreased feed intake. And I suppose often you might say, well, I don't have a problem with my water, but if you turn around and change it, improve the quality of the water, you may actually suddenly discover that your animals do quite well, do better than what they have been doing. So monitoring the quality of your water to ensure that it's fit for purpose, so fit for your stock, really is very important, because most chemical changes to water quality can't be detected by eye or by smell. The quality of water from your bores, wells, creeks, rivers and farm dams can vary widely. So if you have doubts about the quality of the water you intend to use for stock, it really should be tested. And remembering that your water quality doesn't stay constant either. So therefore you should be using it before you, before you use it, and then, throughout the time that you are using your water. Once you know the quality of your water, then you're able to plan for water treatments to avoid problems that could be caused by poor water quality. And as you're all aware, I'm sure, is during drought, water quality issues are very commonplace. This is generally due because your water supplies start to become low, so salinity, pH and chemicals, they start to get higher than normal concentrations. And in surface water supplies, your algal blooms can occur, which they obviously have the potential to be harmful to animals. The New South Wales DPI does turn around and undertake water testing, and information is available on their websites. So I thought I'd just turn around and finish up with a few examples, and please don't hold me to these exact sums. I'm trying to give you a ballpark of managing erosion and the benefits for your farm profitability. So we turn around and think about stock deaths, trying to reduce stock losses due to misadventure. Here we've got a number of different animals. We've got, say, a merino wether who's turned around and gone near some of those lovely erosion gullies that Lori showed us. has fallen in and ends up drowning. That's $170 just in one animal. We've got a crossbred ewe caught in the waterlogged soil, $300 odd. We find a heifer who's been pregnancy tested in calf, falls down one of the gullies and breaks a leg, so is either found or has to be humanely dealt with, $2,400. Or we've got a weaner steer who, they've been playing around, getting a bit too close to the edge of one of the gullies, slips down once again, and that's $1,700 that you have lost in the current prices. So certainly if we can reduce stock deaths, that's going to improve our farm profitability. Breaches in farm biosecurity. So if we're going to improve our farm biosecurity, that can also turn around and help us with profitability. So an example that I've given here is sheep body lice. So sheep become infected, you turn around, you've either got a stray coming into your place, or your sheep go out and mix with, I wouldn't want to indicate that your next door neighbour might have lice, but mix with some sheep that has lice. You turn around, get them all back in again, and you've now got a flock that's infected with sheep body lice. So this can turn around and have production losses, both from a wool perspective as well as from a live weight gain. Your cotted wool or your matted wool is worth about 10% less than your non-matted wool, along with the fact that you're also going to get 10% less wool being shorn. So for this particular shearing, you could end up with having a loss of, say, $500 per wool bale. Not only does lice affect the wool, but the sheep tend to eat less because they get quite stressed, because they're really irritated. So therefore they don't necessarily do as well as they could and put on weight. Plus you've also got the potential to have sick animals as well. They're much more susceptible to fly strike, and you might actually get them to the sale yards and be told that you're not allowed to sell them. You have to take them home, get them off the premises. The other cost obviously is treatment costs. $3 a sheep. I don't know whether that doesn't sound much, but on top of that, you've got the labour, time away from your other duties, along with the fact that maybe that first treatment doesn't quite do the job and you've got to go back and do it again. So there's a significant cost if farm biosecurity is breached. The bottom dollar, I suppose, with respect to livestock production gains, studies have shown that the more water an animal drinks, the more feed it's going to consume, and this leads obviously to greater weight gain. So one study found that water available in a trough rather than dams had positive effects on steer performance. So this particular study had beef restocker steers. They were around about 15 months, weighing around about 190, 200 kilos. They were in a pasture, native pasture, paddock, and then they had with just normal shade, normal feed, nothing extra. One lot, or not, there were 8 paddocks, so 4 of those paddocks had dams, 4 paddocks had troughs. And what they found over the 3-month period, in general, the dam steers spent more time drinking water, but the trough steers actually increased the number of drinking events throughout the study. Interestingly enough, when you look at the dam steers spending more time drinking water, I'd imagine that's probably them standing in the water as well, and animals have been observed to certainly defecate a lot more standing in water, so probably that dam water was a lot more turbid as well. But the steers supplied with water in a trough gained more weight and were heavier than the other group of animals at the end of the study. So if you're looking at over 3 months, the trough steers gained 9 more kilos than the dam steers. That would, in current markets, I suppose, mean between $50 a head more in your pocket. And I suppose the last one with respect to farm productivity would be the loss of stock due to waterborne diseases or toxicities. And in this particular example, blue-green algae poisoning occurred in yearling cattle. 5 out of 30 animals died. The initial inspection of the dam didn't actually show much blue-green algae, but on the second visit, it was revealed that there was a large algal bloom within the dam water, which appeared like green paint below and on the surface of the dam. So you're looking at the loss of, 5 young animals worth around $2,000 each. So that's a livestock loss of around about $10,000. So in summary, while stock will drink a wide range of water types and survive, good water quality is important for stock health and for productivity. Knowing your water quality allows you to plan for water treatments to avoid problems caused by poor water quality. And managing erosion can result in long-term benefits for stock health, livestock productivity, and therefore farm profitability. So thank you very much.